Hello, this is Mr. Huber. In this lesson, we're going to learn about literal equations and how to rewrite and solve them. Okay, so a literal equation is an equation that has two or more variables in it. And we can solve literal equations for one variable in terms of other variables. So that means our answer is not going to be x equals 5, but it might be x equals 5y plus 7. Okay, something with another variable or more than one variable in it. So we're not going to get an exact value, but we're still going to be able to get a variable by itself. Let's see what that would look like. Okay, we have two examples here. This first equation might look familiar, right? This is not a literal equation, it just has one variable. Over here, we've got multiple variables. We have a, x, b, c. We have 4 different variables. And we're going to be able to get the x by itself over here. We're just not going to know that x equals, let's say, 5. We're going to x equals something with a, b, and c in our answer. How would we solve that? Well, let's look back at our first equation here. How would we solve this? To get the x by itself, we want to isolate the variable by using inverse operations. So we're going to start by subtracting 3 on both sides. When I do that, I'm going to get 4x equals 20. And then I could divide by 4 on both sides. So I'm going to get ahead to my answer. Divide by 4 on both sides, and we get x equals 5. So how do I solve the literal equation? Again, this next example, this is a literal equation. It's an equation with 2 or more variables, in this case, more. So I want to get the x by itself. I'm going to subtract b on both sides, just like if there was the 3 there. I'm going to subtract b on both sides. And when I do that, it cancels out. I'm going to get ax equals c minus b, right? Just like we had over here. 23 minus 3, that's what 20 is. 23 minus 3. Well, this is c minus b. Whatever c and b are, we can't actually subtract them, so we just leave it as c minus b. And then we're going to divide by a on both sides, just like we divided by the 4 in the other problem. So now we're going to get x equals c minus b, all divided by a. And that would be our answer for the literal equation. That would be x equals c minus b all over a. Right? So we solve them the same. Instead of adding and subtracting numbers, dividing by numbers, we're going to do that with variables. Okay, to get that literal equation solved for one of the variables. We could solve it for any of them. We could solve that equation for b or c or a. In this case, we solved it for x. So keep that in mind. We're going to use the same steps we would have normally to solve the equation, except we're going to get an answer that's got other variables still in it. So if we look at our next problem, okay, we're going to solve these for x. Okay, we're trying to get this x by itself. If it helps, what you could do is you could take this and say, okay, what would I do if there were numbers there? Okay, what would I do if it was, let's say, 20 plus 3x equals 7? Okay, what would I do then? Well, I would subtract the 20 on both sides. Okay, so in this case, I'm going to subtract the by on both sides, right? Just like I would anyways. So I'm going to have ax equals c minus by. And then after I do that, what would I do? In this equation on the right here, I would divide by 3. Okay, well, I'm going to do the same thing. I'm going to divide by, in this case, instead of a 3, I'm going to divide by a. So I can divide both sides by a. And I'm going to get x equals c minus by over a. And that's my equation solved for x. So it helps write an example with numbers in there in place of the other variables and just see what would I do and do the same thing. In this next example, I'm going to solve for x plus m over n equals h. So we have a fraction there. How would I solve that? I would multiply by the denominator, right, to cancel that out. So I'd multiply by n. It cancels it out. I'd have x plus m equals h times n. I could just write them next to each other. And then I could subtract the m on both sides. Get to get the x by itself. Now I'm going to have x equals hn minus m. And I solved that for x. So keep in mind, what would I do if there were numbers there? What would I do in this problem? If this was a 5, I'd multiply by the 5 to cancel it out. So I'm going to multiply by whatever that n is. And then when I get x plus m, how would I get the x by itself? Well, I'd want to do the inverse of adding m, which is subtracting m. So inverse operation is just inverse of a variable instead of inverse of a number. If we look at a couple other examples here, we're going to get these solved for y in terms of x. That's where we're going to be familiar with the vocabulary. In terms of x. That means we're going to get y equals something with x in it. Y is going to be something that depends on the x. It's in terms of our x value. And that's helpful when we're going to graph lines as we go forward. You might see linear equations, and we're going to get a y equals. So we want to get here the y equals something. We want to get the y by itself. So what would that look like? In this first one, I could subtract x on both sides. Right? I have 3y equals 9 minus x. And then I could divide both sides by 3. And I get y equals 3 minus 1/3 x would be one way to write that. You could just keep it as a big fraction, 9 minus x over 3. Okay, but in this case, I could also do 9 over 3 is 3, and there's a 1 here over 3, 1 over 3. So these are both acceptable for y equals something in terms of x. That's what it means by in terms of. So y is equal to something with x as one of the terms in the answer for y. So now we're going to look at our next example, and we want to get the y by itself. So negative 6y minus 8, again, we want to cancel out addition or subtraction first, so we're going to add 8. I have negative 6y equals 3x plus 8. And now when I divide by negative 6 on both sides, pay attention to the sign. I'm divided by negative 6. I get y equals 3 over 6 would be 1/2, so negative 1/2 x. And then minus, because 8 divided by negative 6 is going to come out positive divided by negative and negative, 4 over 3. I can just simplify that. So I get y equals negative 1/2 x minus 4 over 3. You should be trying these. Why don't you give a shot here to number 5. You can pause the video, try it, play it, and see how you did. Now that you've had a chance to try number 5 out, we're trying to solve for y in terms of x. We're trying to get the y by itself. I'm going to subtract 7 on both sides. So when I do that, I get 9y equals 18x minus 7. Now I'm going to divide by 9 on both sides. I'm going to get y equals 18 over 9 would be 2x minus 7 over 9, just keep as a fraction. 7 over 9, that's a 9, not an a. All right, so y in terms of x. This next example, I'm going to subtract 6x on both sides. And I'm going to get 2y equals 10 minus 6x. If you write that as negative 6x plus 10, it's the same thing. That's fine. You can do that as well. Now when I divide by 2, I'm going to get y equals 5 minus 3x. That'd be the same as y equals negative 3x plus 5. Those are both the same thing. The 3x, that's the negative 3x, and the 5 is a positive 5. So either one of these would be acceptable. That's y by itself equaling something in terms of x. All right, before we do some more problems, diamond direction. Why are left-handed people called southpaws? Why are left-handed people called southpaws? Diamond is a clue there. A lot of people think it's because of boxing, because a lot of left-handed boxers are called southpaws, but that's not where it originates. It's from another sport, baseball. All right, baseball diamonds were always oriented east to west. And so if we look at this, if we had a pitcher standing here on the diamond, okay, the south side of the diamond would be where his left hand is. So left-handed pitchers were called southpaws because their paw, their hand, was on the left side of the diamond. So that's why left-handed people are called southpaws because of baseball pitchers, their left hand being on the south side of the diamond as they faced home plate. All right. Now that we know that, let's see some more literal equations. And we use these for formulas. Right? A perimeter formula for a rectangle is 2 times the length plus 2 times the width. We might want to rearrange that. We might want to know what L is equal to or W is equal to. This is an example of a literal equation. Formulas are literal equations. They have usually multiple variables in them. So if we look at this and we want to solve for length, okay, solve for length, that means I want to get the L by itself. I want to get this L by itself. So how can I do that? 2L plus 2W. Again, we want to cancel out addition or subtraction first. So I'm going to subtract 2W. So I subtract 2W on both sides. I'm going to P minus 2W equals 2L. Now I want to divide by 2 on both sides. So I have P minus 2W over 2 equals L. That could also be written as P over 2 minus W if you wanted to simplify. P over 2 is P over 2, and then the 2 over 2 would simplify to 1. Don't forget the negative sign, so negative 1W. Those are both the same thing. It doesn't matter which way you write it. Either one would be a proper solution for the length in terms of, in this case, perimeter and width. Okay, so we have 2 variables. This is L in terms of P and W. Remember, that's the way we can word that. In terms of means we're getting the variable equal to something that's in terms of other variables. All right. Let's look at one more example here with a formula for the area of a triangle. The formula for area of a triangle is 1/2 base times height. We want to solve this formula for the height. We want to get the h by itself. So with a fraction, how can we cancel out a fraction? We have the 1/2 there. If we want to cancel out, we can multiply both sides by 2. So I'm going to rewrite that formula down here just so I can write on it a little easier. 1/2 base times height. Right? So I can multiply this side by 2 and this side by 2. I'll get 2a equals BH, because the 2 and the 1/2 cancel each other out. And I want to get the height by itself, so now I need to divide by B. So the height equals 2A over B. So height is equal to 2 times the area divided by the base. Right? How would that be useful? Let's see an example here, right? We rewrite these formulas for a variable in terms of other variables. Well, in this example we're going to see here, right, the area of the triangle is 64.4 square meters. What's the height? We have also a base down here, right? This is the base of the triangle, 14. So we have the base and we have the area. So we could find the height. Now we know how to find the height. We plug that in for the A and the B. So we know that height is equal to 2 times the area, 64.4, over B, which is 14. Right? So we can plug in our information for the A and the B and solve for the part we don't know. That's where this would be useful. If I wanted to find the height, like I do in this problem, I can use now that formula rewritten, that literal equation formula rewritten, solved for H. And I'm going to do 64.4 times 2 and get 128 over 14. 128.8. Sorry, I almost forgot my 0.8. Don't want to forget that. All right. So now I can do 128.8 divided by 14, and I'll get the height as 9.2 meters. So we can rewrite formulas for a variable in terms of other variables, solve for a variable the same way you would any other time. Add and subtract on both sides to cancel out addition and subtraction. Multiply and divide on both sides to cancel out their inverses, and get that variable by itself. Keep in mind that you're going to get answers here that aren't an answer of x equals 5 or x equals -2, but you're going to x equals 3y plus c, or something else like here, h equals 2a over b. Right? Those are literal equations. Formulas are examples of that. So a literal equation has 2 variables in it or more, and we solve those for a variable in terms of other variables.